Hello everyone. In this video we draw the Turing machine for the palindrome. So we know that the palindrome can be even and can be odd also. So if we consider the example A B A, so this is the odd palindrome and the Turing machine kept all this string in the tabs. So we draw here tabs. Let's suppose we string like this also, or kept this as it is. Now null, then a number of symbols is the present, so this is for the odd. Now even also, let's suppose A B or B A, because here we start with A, here we start with B, let's suppose. So B A B, null and null. So this is the even palindrome. Now which logic we built here? So first we read this null value. When you read the null value, shift to the right side, move to the right side, then you read this string, either A or either B. So in this case we read A. Then if you read this string, any symbol, then transfer this to the or change to the null. This first symbol transfer to the null and move to the right side. Then all the symbols after this symbol kept as it is and just move to the right side all. If here 100 symbols is the present, then 100 symbols kept as it is and just move to the right side one by one. When at the end you read the null value. When you read the null value, then kept this null as it is and now transfer to move at the left side. Here from this we move to right side. Now when you read this null value, start to travel in the left side. Then first symbol which is present here, change this symbol with the null, and obviously which symbol is present at the starting, this same symbol is present at the end also, because this is the palindromes. If here B is present, then first we null the B from this right side. If here is A is present, then from the right side we null the A. So after this symbol, move at the left side. So all these symbols which are present in between these two symbols just kept as it is and move to the left side one by one. So in this way we travel all the left side symbol and we reach to the, now we are for this example we are now here B. So kept B as it is, move to the left. Then we read null value. So when you read the null value, then again the same cycle is performed. You move to the right side first, then which symbol is just present before the null value, kept this null value as a null and move to the right side and travel all the right side symbols, and at the end you read the null value. So in this case our all the symbols are transferred to the null, means we can say that we are read all the palindrome symbols and we are in the acceptance state. But if the n number of symbols is present, that time also we by using this cycle we convert all the symbols to the null, and then at the end when you read all the nulls, then we accept this string. So we draw now this logic, means we draw the TM machine. So let's start. So let's suppose now we start with the even palindrome, because now this is we discuss, this is the remaining. So when we draw the TM machine, that time this we cover one by one. So at the initial state, Q naught state, first we read null value here, this null value, So first we read null, then kept null as it is, move to the right. We move to the here B. So now we are in Q1 state. So in this Q1 state we have two options. Either we read A, either we read B, or either we read A, because string can be start with A also and B also. So from this state we have two options. Here is for A. Let's suppose A, then change this A with the null and transfer to the right side. And here if you read B, then B, transfer this B to the null and move to the right side. So now here we are in Q2 state. This is the Q2 state, this is the Q3 state, let's suppose. So we are now here. Now for this state, after that when you convert this symbol to the null, then we just travel all the symbols one by one and kept this all the symbol as it is, and we reach to the null. So for that we write here the transaction like this. If you read A, kept A as it is and move to the right, and if you read B, then kept B as it is, move to the right. So this transaction will form. So by using this we completely reach to the right side and we read the null. So here we can say that after reaching all the right side symbol, if you read null, then keep null as it is and start to travel at the left side. So here is the left side. Now after this B, we travel here. So we read A, kept A as it is, move to the right. We are here now. Again we read A. So again this transaction, this cycle is formed. So we kept A as it is, move to the right. Then we read B. So again this cycle is formed. We kept B as it is, move to the right. We move to the right. Now we read the null value. So for that, if you read the null, kept null as it is and start to travel at the left side. So we are now here in this B. But we null the B now. So same, which transaction we write for the A, same transaction write for the B also. I forget, we start with the B now. So this same transaction right here. So A and right. Same cycle is formed here also. B and right. The main difference is if you start with A, then travel this cycle, and if you start with B, then travel this cycle. Now here null and R. Same. First you read B, converted into the null and move to the right. Then all the symbols just read and move to the right. Then you read null, then start to travel at the left side, not right, left side. Now you read B. When you read B, here the Q, let's suppose Q4 state, and this is the Q5 state. After this you read the same symbol which you first converted into the null. So here in this case I convert the B. So here is the, let's suppose Q6 state. So when you travel at the left side just before the null value, then this symbol is converted into the null. So B converted into the null and move to the left side. Same for the A also, because if you first convert the A to the null, then just ending is end with the A. So here we start with A, so here we end with A null and left side. Now after that all the string we kept as it is, and just move to the left side one by one. So if you read now here, if n number of a's kept as it is, move to the left side. If you read b, kept b as it is, move to the left side. So now we are here, we read b, transfer this b to the null and move to the left side. Then we read a, so kept this a as it is and move to the left. Now here we again we read a, so kept this a as it is, move to the left. Now we read null value, and when you read the null value, then transfer this transaction to the initial state, means q1 state, not for the q not, because here after this transaction no need to travel again for this next null value. We now move in the right side direction, because from this cycle, as I say, we convert all the symbols, so no need to go here. So instead of connect this q0 state, I connect this q1 state. So null, kept null as it is and change to the right side. Here after this string we read the null value, then kept this null value as it is, and now travel at the right side. So we travel at the right side, and now we are here in this state. Now after this we now read the a, so now we travel by using this path. So if now we write a, so transfer this a to the null, and now all the symbols after this null value kept as it is. So we read b, so kept a, now we read a, so kept a as it is, move to the right. So we now read null. If you read the null, then move at the left side again and transfer this a to the null. So this null we transfer. After that, if the symbol is the present, then kept all the symbols as it is and read to the null, and this cycle is good here for the q1. But in this case, after reaching this null value, means we travel here, then again we read null value. So here from this q1 only two transaction is present, for the a and for the b. No transaction is present for the null, and this when we read at the final at the null, that time we are in the final state. So null, kept null as it is and move to the right, and here we are in the final state q7. So this is the Turing machine we draw for the even palindrome. If you put any palindrome here, then the same we are at the end come at the final state. So this is for the even. Now just by using some changes, we add the all palindrome is also in the same Turing machine. So for that we travel the odd symbols. So let's we travel one by one. So let's suppose we start with the a. First we read the null initially, so we are in q1 state. After the q1 we read a, so we travel in this direction. So we read a, then change this a to the null and move to the right. Then all the symbols a and b kept as it is and move to the right. So we read b, kept as it is, move to the right. A, kept as it is, move to the right. Then we read null. If you read the null, then move to the left side now. So we move to the left side. Then this a converted into the null and move to the left side. So we convert this a and move to the left side. After that, all the symbols which are the present kept as it is and just move to the left side. Even where we read the null, that time transfer this cycle to the q1 state. So we are now read this a. So after that we travel by using this path. No, this path, because after this null value we shift to the left, we shift to the right here. null, null and right. So after this we shift to the right, we read the B. So after this B, we transfer this B to the null. So we convert this B to the null and we reach this state. Now after that, after move the right side, we now read null value, but here the transaction is not present. So what I say, when we shift to the right side, we read the null. So kept this null as it is, move to the left. So again we come here for the B. So here we now read the null value, not B. This B is converted into the null. So after this transaction, no transaction is right for the null value. So this transaction is go here at the final state. So null, kept null as it is and move to the right. And this is the acceptance state for the odd palindrome. Same for the A also. If in the middle A is present, that time we come the transaction in this direction. And here we read null, null and right. So this is the Turing machine for the palindrome, even and odd both for this. So this transaction, this TM machine we write in the simple words also. How? So let's in the initial Q0 state, and we want the palindrome is like B, A, B and null. This is the palindrome, simple. So at the initially we start to read this null value. When you read the null value, we reach to the Q1 state. So right here Q1 state, and this null value kept as it is, and BA, BA. We kept this null value as it is here, and the transaction is complete for this. After this null value, we read B, and when you read the B, you are in the Q3 state, and transfer this B to the null. So we are in Q3 state, then this null value, here is the B which we transfer to the null, and we read to the A, and B null. After this B, we read A. Then what we do, kept this A as it is. So we are in the same state, Q3 state. So this state are depend on in your TM machine, Turing machine. If you write here Q4, then instead of this Q3 you write the Q4. If you write Q10, then instead of this Q3 you write Q10. So don't copy as it is from this video, because this is depend on the Turing machine. So check your state and then write here. So null, null, now A. If you read A, then kept A as it is and move forward. Now we read B, kept as it is. Now from this Q3, if you read B, then B kept as it is, move to the right. So Q3 now kept as it is, because we are in the same state. Then null, null, A as it is, B as it is. Now we read this null value. After this B, we read null. So if you read null, then move to the next step, Q4 state. So Q4 state, and after this null value, move to the left side, means we read now B. So this null, null A and the B. This null kept as it is. If you read this B, then convert this B to the null value and move to the left, and we reach to the Q6 state. So you read B, then we reach to the Q6 state, then this null, null as it is, A right as it is, and convert this B to the null, and this initial null as it is, and now you read A. Then if you read A, then kept this A as it is. If you read this state, here we form the cycle and move to the left. So here we write, we are in the same state, Q6 state, null null, this A as it is, and transfer this null, keep this null as it is. Now what we do here, we kept this A as it is and move to the left. So move to the left means here. So after this read A, not move right side, move to the left side means in this direction. Here we move here. In Q6 state, if you read A, then kept A as it is and move to the left. So that's why we write all the transaction as it is and just we transfer this arrow to the left side. Now after this, if you write the null value, then kept this null value as it is and move to the right side, and this transaction is done in Q1 state. So right here in the Q1 state, if we read null value, then kept this null value as it is and move to the right. So we move to the right. So this A means we move to the right, this arrow is moved to the right, and null null. Now the Q1 state, here in this Q1 state, if you read A, then transfer this A means convert this A to the null and move to the right. So we reach to the Q2 state here. After this Q1, we reach to the Q2. So right here in Q2 state, if you write this A, then convert this A to the null, because in here A transferred to the null and move to the right. So we convert this A to the null and remaining all is as it is, and we only shift to the right side. After the right shifting, if you read the null value, then kept this null value as it is and move to the left. So we move to the left. Now next state, which state? In Q5 state we now. So Q5 and null null, null null null, and after this reading null, we reach to this null. So again we read the null value, and now if you read the null value, then transfer to the Q7 state, which is the final state. So after this Q5, we read Q7, we are in Q7, which is the final state, and all the null value kept as it is, and this is the final state. So from this transaction we can say that we draw the Turing machine correct. So I hope all you get idea about this example also and this Turing machine also. Now if any doubt or any query regarding this, then let me know in the comment box. Thank you.